This flawless lipstick looks simple now, but its color began as loose pigment that could stain an entire batch in. Before the shine, the smooth bullet, and the perfect edge, there is only concentrated pigment powder and a demanding formula. How does this unstable-looking powder become a uniform luxury lipstick without streaks, bubbles, cracks, or a shade that drifts? The process starts inside a controlled cosmetics plant, where every container is isolated, checked, and routed before. Color is treated like a precision ingredient, not decoration. Contamination here can follow the material all the way into the finished bullet. A premium shade may be adjusted in increments as small as 0.1 gram, which makes the first weighing step surprisingly important. It divides one lipstick formula into tightly controlled stages, so each room solves a different problem before the color moves forward. The powder can look perfectly uniform from a distance, yet small clumps can later create streaks that only appear after molding. Everything so far protects the raw color. The next room begins changing its physical state, and that is where the real process starts. Each pigment batch is inspected before opening because moisture, damaged seals, or foreign particles can ruin consistency long before mixing begins. At this stage, the color is extremely concentrated. A tiny amount can shift the appearance of kilograms of lipstick base. Sorting prevents the wrong pigment family from entering the same formula, a simple control that protects the shade before any machinery is involved. Weighing looks ordinary, but one wrong dose can shift the entire shade. The strangest transformation has not even started yet. The strange part is still ahead. These dry powders must become a smooth color phase without leaving even microscopic-looking clumps behind. Under macro magnification, the powder behaves less like paint and more like dust, flowing into ridges that later must disappear completely. Once weighed, the pigment stays covered during transfer, so the exact dose reaches the next room without loss or cross-contact. The raw material has now crossed from storage into processing, but it is still dry, clumped, and too unstable for a luxury formula. Experienced operators watch how the pigment settles and spreads, because flow behavior can reveal before the powder reaches the screen. One visible clump is enough evidence that the powder needs mechanical screening before oil can wet every particle evenly, under controlled factory conditions. The preparation room is designed to make every movement short and controlled, reducing spills while keeping each measured batch tied to one formula. The powder enters the screen in a controlled stream, because dumping it too quickly can overload the mesh and leave clumps untouched. Every station pushes the material one way, which matters because reversing containers through clean and unclean zones raises contamination risk. The pigment is measured and positioned. The next act removes the dry clumps and gives every particle its first coating of oil. The vibrating mesh breaks soft clumps and removes oversized particles, turning the raw batch into a more uniform sifted pigment powder. After screening, the powder settles more evenly, but dry particles still resist the oily lipstick base until their surfaces are fully wetted. The screened powder now moves directly into pre-mixing, where oil begins replacing trapped air around the pigment particles. Oil is added before the full wax base, so the pigment can be wetted gradually instead of floating as dry islands on the surface. As oil surrounds the particles, the material changes from loose powder into oil-wetted pigment paste, the first major state change in the process. The paste should spread smoothly instead of breaking into dusty islands, a simple visual clue that the pigment surface has been wetted. The first color check happens before wax is added, because correcting dispersion becomes harder once the formula turns hot and viscous. Every portion of oil-wetted pigment paste leaves in a closed line, keeping the measured formula together as it approaches the main mixer. Why can a smooth-looking paste still fail later? Hidden pigment clumps can survive mixing and reappear as drag across the finished lipstick. A smooth smear reveals whether large clumps remain. Visible specks at this point send the batch back for additional dispersion. The next machine must do more than stir. It has to distribute pigment so evenly that the finished color looks continuous at close range. The thick flow shows why simple stirring is not enough. The mixture carries resistance that can trap uneven color zones inside the batch. By the end of pre-mixing, every pigment particle should be surrounded by oil, ready for the mechanical force that comes next. Dry pigment is gone, the next act combines heat, wax, oil, and shear to create the lipstick mass people actually recognize. Formation starts with the base. Waxes provide structure, while oils and emollients control glide, shine, and how the bullet releases color. Heat turns the structured wax blend into molten wax and emollient base, creating a continuous liquid phase ready to accept pigment. Recirculation evens the temperature throughout the vessel because cold zones can thicken early and disturb pigment dispersion later in the batch. Many lipstick bases are processed within controlled warm temperature windows, high enough to stay fluid without damaging sensitive ingredients. This is the most expensive part of the visual story. Every earlier step exists to prepare two phases that can finally become one. Liquid looks simple, but its final behavior depends on how completely the pigment phase is distributed through this moving base. Pigment enters gradually so the mixer can pull each addition into the base before another concentrated pocket reaches the vessel. The critical step is dispersion, not molding. Uneven pigment here can make a lipstick look rich in the tank, but the batch now has to prove uniformity, because color that changes across one smear will never become a premium finished bullet. Mechanical shear breaks remaining agglomerates and spreads the pigment through the base until visible specks disappear from the color film. The formula has crossed the impossible-looking gap from dry pigment and clear wax into one glossy, continuous lipstick color mass. The ribbon should remain smooth and even from edge to edge. Graininess here signals incomplete dispersion and another pass-through mixing. Once color is uniform, the batch moves forward without returning to dry processing, preserving the material state that the molding line expects. Even a perfectly dispersed color can still fail visually if air remains trapped, because bubbles can become pits inside the finished lipstick. Vacuum de-aeration removes trapped air before molding, turning the glossy mixture into a denser, calmer mass with fewer internal voids. This quiet surface is the payoff of dispersion and de-aeration. The color is now continuous, fluid, and ready to take a precise shape. One stray particle can scar a perfect bullet downstream, so the seemingly finished color mass still faces one last barrier before molding. The chemistry and mechanics are finished. Next, a liquid color mass has only minutes to become a perfectly shaped lipstick bullet. Molding begins with geometry. Each cavity must be clean, aligned, and ready before the hot mass leaves its controlled holding temperature. The cavity surface determines the visible skin of the bullet, so tiny debris here can become a permanent mark after cooling. The material now has one direction only, from the warm holding tank through the manifold and down into the waiting mold cavities. Monitoring temperatures. As soon as the hot mass fills the mold, the next challenge becomes temperature, because cooling determines whether the surface stays smooth or cracks. Cooling too quickly can create stress, while cooling too slowly can soften edges or dull the surface, so timing matters. The liquid must settle before it locks into place, because every ripple that survives becomes visible on the final bullet surface. Inside the tunnel, the same formula that flowed like thick paint begins rebuilding its structure as wax crystals form through the mass. Bullet is created by controlled solidification, not simple freezing. The structure must become firm without trapping stress inside the shape. The first reveal is still hidden inside metal, and this is the moment operators learn whether the batch survived filling and cooling cleanly. A few minutes earlier, this material was fully molten. Now it can hold the sharp geometry consumers recognize immediately. The glossy color mass finally becomes separate cooled lipstick bullets with clean walls, sharp tips, and consistent height. Fresh bullets remain fragile, so the line supports them from below and keeps their finished surfaces separated during transfer. The transformation is now visible at scale. Every lane carries the same color, same profile, and same direction toward finishing. The smallest edge defect is easy to see on this geometry, which is why the first inspection happens before assembly into a tube. A short finishing step can restore gloss after cooling, turning slightly dull cooled lipstick bullets into polished, finished lipstick bullets. The bullet now looks finished, but it still has to survive alignment, tube insertion, shade checks, and repeated handling without damage. Finishing removes the last visual distractions, so inspection now focuses on symmetry, gloss, and whether every tip matches the intended profile. A premium bullet is judged before use. Smooth highlights reveal whether the surface is continuous or broken by pits, scratches, or haze. The tube is not decoration yet. It is a mechanical support that must grip the bullet straight and raise it without wobble. Guided insertion keeps the bullet centered, because a slight lean can scrape the sidewall when the consumer twists the mechanism upward. The machines have nearly finished shaping the product, but from here, a trained human eye can still reject flaws automation misses. The bullet must travel vertically without rubbing the wall, a simple movement that exposes alignment errors faster than visual inspection alone. Human inspection remains valuable here because tiny lean, chipped edges, or uneven gloss are easier to notice as the bullet turns. This is where industrial scale finally becomes visible. Hundreds of identical motions turn individual bullets into a continuous stream of finished products. Color is checked under controlled light because a shade can appear warmer or cooler when the illumination changes between rooms. A single smooth stroke proves what the entire dispersion act was trying to achieve: uniform color release with no gritty specks or patchy gaps. The product now looks effortless, yet every clean highlight depends on controlled powder handling, dispersion, cooling, and alignment much earlier in the line. Repeated movement tests can reveal rubbing or looseness before units reach packaging, where defects become harder to separate efficiently. The goal is consistency across the whole batch, not just one beautiful bullet.
Okay, measuring now.
Ensure the finish matches the swatch exactly. The cap protects the finished surface during transport, and a clean fit conforms the mechanism sits at the correct height inside the tube. Only after color, alignment, movement, and cap fit pass inspection does the product leave assembly and enter the shortest act of the factory. Difficult transformation is complete. What remains is proving consistency, protecting the product, and sending it beyond the factory walls. Final checks look for small variations in mass, height, and finish, because tiny assembly differences can signal problems elsewhere in the line. The profile must stay symmetrical from every angle. A visibly uneven tip can reject an otherwise perfect-looking lipstick before packaging. A controlled light booth removes much of the room-to-room color shift, giving inspectors a repeatable reference for batch consistency. Packaging is deliberately simple here. Protect the bullet, prevent movement, and keep approved units separated from anything still awaiting inspection. After more than a dozen controlled stages, the product finally becomes packaged luxury lipsticks ready for storage, and factory story could end here. But the final 12 scenes answer the bigger question. Where does this carefully controlled color go next? Packaged luxury lipsticks leave the clean production floor in sealed cases, moving from controlled manufacturing into the ordinary logistics network outside. Once the doors close, every protected case carries the same promise. The lipstick inside should look identical when it reaches a customer. A plant like this may ship thousands of lipstick units per production day, which makes tiny process errors multiply quickly. The product has left the factory, but consistency still matters because store lighting makes differences in gloss and color easy to notice. Retail shelves compress the whole factory journey into one glance, where the customer sees only finish, shade, shape, and packaging quality. Nothing on the shelf reveals the powder, heated kettles, vacuum vessel, cooling tunnel, or inspection rooms hidden behind this finished object. The transformation becomes personal here. A product chosen in seconds required controlled material states and repeated checks across the entire factory. For the customer, this is an everyday purchase, but the product still carries the consequences of every earlier decision about color and structure. The lighting changes from cold industrial white to warm household daylight, signaling that the engineered object has finally reached its real setting. Now every smooth highlight has context. Dispersion created the color, cooling created the shape, and inspection protected both before this moment. The final test is ordinary use, where glide, even color, clean edges, and mechanical alignment all become visible in a single familiar motion. It began as loose pigment and ended as this precise everyday object. Now the simple lipstick no longer looks simple at all.